if that's all right. All right, hi everyone. Friday, 23rd of July, Open Source Antibiotics Series 2. And I'm going to share the relevant thing. Now, the first thing I was just going to mention before I forget is that holidays are coming up, right? And our resident potency tester, Paul Stapleton, is going to be doing some vacation and essentially is able to do another screen for potency of compounds if we get them to him ASAP. And by that, I mean like Monday, Tuesday. So we've got compounds that came in from Northeastern, which is fantastic. Thank you so much for sending those in. And of course, we've got some local compounds as well from Dana and Giada. And we may potentially have compounds from Flavio, but it depends how it's going. But is it kind of worth it and reasonable to stick those in for an assay essentially next week? How would that be?
Yeah, I think that sounds.
Dana, don't you have the compound that has the totally changed from the pyridyl to something like thiazole, right? You have that?
Yeah, I've got the thiazole and the pyrrole.
Oh, that's actually, that will be very interesting to see, because not exactly how sure how stable an unsubstituted pyrrole is going to be.
So that would be then these 7, and then 8, 9, and then 10, 11 Giada, and then 12 control compound. So I guess it's worth it, right? No matter what.
Yep.
I think so.
And all of those would be good to go on like Monday, Tuesday kind of thing?
Yeah, should be.
All right, let's do that. Great. I'll send the mail. I just spoke with him yesterday, and I'll send the mail to him after this meeting to say that we think there'll be some compounds coming in. That's great. He's got a bunch of stuff before he needs to do it before he's away on vacation, but he's in the school next week and can do some testing.
Cool.
Yeah, that's good. But then we'll have like a 3-week hiatus, I think, because August is August. Okay, that would be really good. So that's the first thing. Yeah. Second thing was, so this archive thing about benzimidazole is going to DNDi. We keep missing that out. We're not doing that anymore. Are we doing that? I can't remember what. Yeah.
Yes, I emailed Lori about this actually. And you're happy to have them, right, Lori?
Yeah, and I did.
Yes, you did. I'm sorry.
Email with you, Ed, as well.
Yeah.
Yeah, we've emailed about this, and we've emailed about this. It's happening. We sent vials to you in our last shipment, so yeah, we should be good to go now.
Yeah, we haven't put that together yet because we've been trying to get Giada finished up mostly, I think, but hopefully we'll try to shoot for next week, maybe. Yeah.
Awesome.
Cool.
How many compounds are coming in for DNDi? Do you know roughly?
10-ish.
Okay, I mean, we may just send out a separate shipment from our.
Yeah, that's cool. I know you told me July 26th, but I just didn't get to it. Sorry.
That's okay. All right.
Sounds good. Thanks. And then speaking of the parallel DNDi assay, so Dane, you very helpfully posted the updated color-coded set of data and calculated some selectivities, all of which look red, pretty much, indicating not great selectivity, but there are some oranges where there is a bit of a window, depending on which data you, I guess you prioritize. And there's been some discussion here about the value of some of these compounds. Laurie, you commented most recently about this in a kind of optimistic way. Do you want to just give some thoughts about this?
Yeah, so I guess a couple of things. If you could scroll back up just for a second to the SIs. So For the assays themselves, T. cruzi uses MRC5 and LN Phantom uses the PMM. So those are the two relevant kind of columns for each. We typically would be aiming for a selectivity window of about 10. So I'd say Dana's probably a little on the pessimistic side with some of the color coding. You know, obviously the less. Yeah, go on.
Sorry, yeah, I wasn't sure exactly what to use, so that's kind of arbitrary on my part. So I can redo them if we think that would be helpful.
No,
but,
it's fine.
yeah.
But looks like you have done the selectivity at 10, hasn't it?
Well, so but I would color those green.
Oh, I see.
And I'd have something like 8.8 as orange. But I guess my thinking on this is in terms of the assays themselves, I would probably be focusing for our purposes, like right now, on the actual MRC5 and PMM values in the comment above this, because that's really, you know, we're not so fussed about the selectivity index. It was more about, you know, what is the potency versus in MRC5 and in PMM for some of these compounds. So that was kind of where I was going from that. I also think it's kind of interesting. You can see, so if you compare OSA 865, which is the third one in on the top row, and OSA 975, which is the second one from the right, like all you've changed there is a methyl to a nitrile and significantly changed and modulated the tox against PMM and MRC5. And so I wonder actually if what we should do is kind of more of an in-depth analysis like that, thinking about, okay, what do we know about the SAR? And then what do we know about the tox side of things, and whether we can actually glimpse in this way now that we've kind of got a bit of a set. That was kind of where I was coming at it from. And the other thing is we were cautioned a couple of months ago to really just be focused on in vivo tox. And if in vivo tox is an issue, then go forward. Acknowledging that these compounds are slightly different, we progressed the N-alkyl derivatives into PK, and there was no tox there. You know, maybe it's not so terrible. Maybe.
Yeah, we were warned about the being misled by the in vitro tox
By the in
data.
vitro data. Mm-hmm.
Separately, I've been trying to figure out if we should submit a bunch of these to the NCI 60 cancer cell line screen, just for extra data. And we can totally do that. Just need some paperwork. I'm assuming that would broaden out what these compounds might be doing in vitro. I'm assuming it's still useful.
What data do you actually get from that? I don't know.
I can't. It's against. Last I checked, it was against 60 different supported cell lines, right? Unless someone's looked at it more recently than I have, which is supposed to give you information on types of tox, isn't it? As far as I'm aware, or potential mechanisms of action and things like that, or mechanisms of tox. That's as far as I'm aware. So a super version of this against different cell lines that we may not have access to. I guess I haven't actually checked if these are part of that. But that aside, so Laurie, are you? I mean, from the data in front of us here, are you more interested here in sort of pursuing compounds with decent potency against the pathogen, or are you interested in trying to just find a pattern that allows us to modulate the tox?
I think both from our perspective. So as Dana mentioned in her comment, for T. cruzi and leash, it's incredibly challenging to actually find a hit compound. And for us, a hit compound is anything under 10 micromolar.
Right.
So a number of these are actually already sub-micromolar. And at that point, you're actually kind of getting into serious sort of levels of potency, yes, the selectivity index then does become relevant. And some of these, it's not amazing.
Yeah.
But we actually think that there could be a path forward in terms of maybe bringing in some, maybe modulating tox and potency. And so Quillon has actually pulled together compounds that maybe we could make with a view towards sort of our kind of focus, which has been on the parasite side of things. And so he's actually shared that list with Dean. I'm not sure if you've put it on the GitHub yet, Quillon.
Yeah, so I briefly put that up last week in the meeting. It's in the slides that I attached.
Yeah.
Right.
So for us, there's a couple of strategies that we could use. One would be to actually sort of pursue the series a little better or a little more for the cruisy leash aspect. And then the other would be actually to have a look at the data and see if we can understand the structured toxicity relationships.
Sorry, Quillon, do you have this if you want to share? Actually, might be quicker than me doing it.
Yeah, bear with me.
Okay, no problem, no worries.
Actually, to be honest, it may be quicker if you just pull up those slides.
Okay, so these slides here.
Yeah.
Okay. All right, I'll do that. I will get out of my screen share for a second. And then, all right, one sec. Get that out of the way. Okay.
So that's the series of compounds that I'm currently going through and making. The idea was sort of looking very briefly at the SAR for the compounds that we got through. We saw a preference for substitution in the 3 position. So I was just sort of looking in through the lens of trying to further explore some of the best compounds that were substituted in the 4 position, like the trifluoromethoxy, for example. And then putting them into 3 position to see if we can get improved tox, which is what occurred when you had the methyl scan going around between the 2, 3, and 4 position. The other component for this series that Laurie mentioned, we have gone into PK, but have failed to get suitable exposure for the compound. So that was for the N-alkyl compounds where we've gone through with the PK. So a lot of our optimizations have been really trying to nail in compounds that are more metabolically stable, as well as soluble in the actual assay as well. So that's sort of why we sort of looked at these compounds with the lens towards lipophilicity, even though I did say, I think just above where I've attached the slides here, that there isn't a strong correlation between lipophilicity and solubility for this series.
Okay.
What if you do a 3 CN?
Well, for Ellen Phantom, the cyano compounds were inactive.
It's very strange.
Oh yeah, there is a 3CN actually. Yeah, right there. Better than the para, but still.
I mean, the other idea is, what if do we know if the smaller 5+5 core is better for the trypanosomes than the 5+6 core? You know, the old, because we're still getting decent potency on
They look to be the same, really, don't they? If you compare,
yeah.
if you compare,
So,
yeah, N865, yeah.
oh, it's identical.
But the thing to note here is that the 5.5, especially the saturated version, has better ADME properties.
Right.
It'd be interesting to know if the metabolites, like the hypha metabolite, we don't have a lot of it, but it'd be cool to see if it was active against the trypanosomes.
Yeah, you can rustle up another 10 megs of that, can't you? No problem.
I mean, we did think about asking, but you know. We figured that too.
I think that may be off the cards. We could try and make it somehow.
I think Quillon actually did look into making it, and it's
Right.
not trivial.
Yeah.
I saw it as a nice handle turn into the fluoro.
So we need to keep on sharing compounds, right? I mean, that's the take home here, I suppose. And keeping an eye on this because, yeah, I agree that some of these fairly straightforward compounds have, particularly with the meta on the ring, have promise. I mean, according to sub-micromolar being of great promise, then yeah, we've got some nice compounds here for sure.
Another interesting one is our inactive control, 820. It's got 2 micromolar potency against the trypanosomes, which is strange.
You mean the inactive control?
For MRSA, it's inactive.
Oh, okay. Yeah, look, I mean, these are completely different organisms. It doesn't shock me that we're seeing. So I'm not super surprised by that.
But that almost looks like that could be something you guys could iterate on, maybe.
Yeah, I mean, I agree, but there's also compounds in this set that are even more potent that I think are a little bit more interesting at this point.
I guess it's a matter of making a wish list of what compounds.
When you're talking about the Emery properties, do you know whether these compounds are absorbed and then metabolized or not?
Don't think we do.
So we only get in vitro intrinsic clearance data for human microsomes and rat hepatocytes. No, it doesn't answer that question.
Yeah. So have you thought about putting them into KCO2 cell line or something like this and trying to get some idea of how well they penetrate membranes, cross membranes?
So we do have access to a KCO2 assay. Quillon, can you remind me off the top of your head, have any of the N-alkyls or the NH been in?
I think that's the one that we recently just sent, and they had issue with solubilities in the assay.
Oh, yeah. Give me a moment. I'm just going to have a look in our database and see if we've got any data.
Good point, Chris. We don't have that, I don't think. I mean, for the set of MRSA actives.
Yeah.
And I'm sure that we could ask somewhere. I had a feeling that NCATs did that for free, but I can't remember.
Well, the other thing would be if you have a MDK cell line with transporters and things like this, and it might give you more information about what the issue is with absorption, if there is one, rather than just solubility.
Right. Okay. Would you could you just dump that as a comment in the issue for today's meeting, just to make sure we don't miss it?
Yeah, sure.
Thank you. All right, I'm just conscious of time because I have a stop at past, unfortunately. And I just want to make sure that we deal with anything else that we need to. So the talks is still going on in the background, and I'm sure Alex will update us soon when she's completed the table that she talked about last time. Current synthetic targets, I guess we talked about those relatively recently, and I don't think that Flavio is here to tell us about the homologous series, unless I'm mistaken. So, and Giada, who's on the call, it's her last day today in the lab. She's writing up thesis and stuff, but it's her last day in the lab, and it looks like she's managed to make another compound, which is very exciting. So I said that I would share a slide, and I don't have it. So you just talk amongst yourselves for like 2 seconds. I will bring that up. Wait. Okay, I don't know how. If you try and share a Zoom, a Teams window from Zoom, it's like a platform fight or something. Sorry. I don't want,
Too many in video chat tabs.
I can share.
Isn't that akin to sort of crossing the things in? Was it
Ghostbusters
Ghostbusters? Yeah.
on the same wavelength. Yeah, never
Across the
don't
stream.
cross the streams. Yeah, Right.
Well,
there it is.
yeah, I don't know exactly what you can see, but
If you scroll slightly, yeah, that's it. Got it. That's
okay.
it. Fine.
Okay.
Mhm.
Okay. This is the compound, and it's kind of similar of the one that we did last week during the last weeks. I just added piperidine here, and I have 44 milligrams. So yeah,
That's great.
that's achievement.
And the previous one with the diethylamine up there.
Yes, was only diethylamine. Yeah, without.
But you have enough of that for testing, right?
Yes.
Great. And your NMRs are beautifully pure, like in a textbook.
Yes, it is.
All right, that is great. So we can put those in the screen next week.
Okay,
Fantastic. Congratulations.
thanks.
All right, really good. So perfect. Anyone else wanted to give a nanochemistry update?
No, just Quillon's purification worked very well for me. So thanks for that, Quillon.
Oh, I'm really glad.
Yeah, finally got something clean out. So I was happy.
So is it a protocol which allows you to do the nasty one pot and then get the thing out first shot, or do you have to do an initial purification and then this?
Well, Quillon does just straight onto a reverse phase column. I don't know how I feel about that because I think that it will stain the column. But I'm gonna try. I'm not seeing, I don't think, the same impurities that you were seeing, Quillon. So I might just try crashing it out of the DMSO solution and see how that goes. But I need more starting material in to make the next analog, so I can try that. But hopefully it will work. But it's getting rid of all the nasty colors and stuff, so I was pleased about that.
I actually just,
Sorry, Laurie.
sorry, go on, Quillon.
I was just going to say that if you find the columns are getting stained by the isocyanide byproducts, I flush it with about, if it's a 30-gram column, with about 300 mils of isopropanol, and that sort of freshens it back up, ready for use.
I was actually going to suggest, I wonder if you could even use like the little samplet loading cartridges, whether that would then just trap the staining on like the loading cartridge, and you could then just turn
Or an acetone flush.
I'm thinking to maybe try crashing it out first, collecting that, and then if I need to purify it by reverse phase, hopefully it would be a bit better. But anyway, I'll just see how I go. But it does seem to be working a bit better than just like trying to column it. So that's good.
Okay, great. And then just the last thing I was going to mention is that on the basis of last meeting, I'm just hassling Lee about whether he's got enough compound to do the next mechanism of action experiments. That was all. And I posted about whether or if we're interested in this proteasome idea, which is, I mean, it's a crapshoot, isn't it? Sort of naming a target and seeing what happens. But if we're interested in that, it sounds like Lee is. I was interested in whether a lab was around that could run an assay that might suggest whether or not a compound's hitting the proteasome. And there is one in Karolinska, and I was going to reach out to the guy who runs that and see what happens. If anyone's got any other bright ideas, then great. It's a chance, but
I mean, because we really don't know, because if you run it through the general machine learning stuff, it's so similar to kinase inhibitors that it just spits that back out at you. I tried using a couple of free services and it all spits out kinase inhibitor, but so we're kind of in the dark as to target, I guess.
Yeah, no, sure, absolutely. To some extent it makes sense just to wait for Lee to do his thing before we do anything, but
So we're We're also about to start a project with Cyclica, trying to see if we can actually look at predicting tox-related issues for chemical matter. And so, I mean, we could also put one of these or a couple of these compounds into that and see if that turns up anything. I have no idea at this point how successful we'll be. But we could certainly try and incorporate that. I had intended to look at the N-alkyl derivatives that we've been sending anyway.
Right. I see you posted about something at UNC Chapel Hill as well, so I'll save that comment. No CACA2 data for compounds, right?
Yeah, we don't have any CACA2 data. We could get some, but the other thing would be, yeah, the psychoactive drug screening program. I was looking to see what assays they have available, and I mean, we've tested through them before. I know it does say that you're supposed to be working on sort of neurological disorders and stuff, but they do test other things.
Right. Okay. Great. All right, that was everything I had. Anyone want to mention anything else? Because we don't have a target yet. We can't do anything fancy with the AlphaFold 2, protein data set thing that was released today and yesterday. But even though it's not actually ready for, analyzing small molecule protein binding, it's still nice to play around with the structures. But this project is not ready for that yet. So nothing we can.
Maybe we can do it for PF-ATP4 in the malaria group.
Oh, somebody did that overnight. Yeah, somebody used
nice.
it to predict the structure of that protein, and they posted it. Yeah, within hours. It was very interesting. But yeah, it's not intended yet for small molecule protein binding. That's the next level, I think.
So the AlphaFold is freely available now, in so much that you can just take a sequence off Uniprot and get a prediction.
Yeah, they've done the predictions for the human proteome and for other species, not viruses, but for other species, and deposited them with.
I think they've done it for Plasmodium, though, haven't they?
So I didn't think they had done it for Plasmodium because the guy that we were talking to ran that and predicted PF-ATP4
Okay.
first. Yeah, I didn't check, but that was the implication.
Okay, you may be right, and maybe I misunderstood what they were. Somebody told me, but yeah, my impression is that they are going to go through all of everything that's available.
Yeah, I think so. Yeah, definitely, for sure. And it's going to be interesting to see how that can be used in drug discovery projects, I guess. And that's the next phase. But it's fantastically interesting. Yeah, I mean, it's beautiful to see these things, for sure. And we'll see if one day we can use it for this project. But yeah, making the source code freely available for the calculation for the software itself is a nice step.
Yeah, well, the Baker Group also did that for their ZetaFold as well.
Yeah.
The Baker Group, the folded people.
Yeah, in Washington.
Yeah. And
right.
I suspect you're going to see more versions of it coming out as well.
All right, thanks for your time, everybody. Really great. And
bye, everyone.
see you next time.